In today's note, we're going to be solving linear systems by elimination. So again, remember when we're trying to solve a linear system, what that actually means is we're trying to find the point of intersection, or the POI. And what it means to solve by elimination, solving by elimination means to add or subtract the equations to get rid of a variable or a letter. So basically, if we're solving by elimination, actually let's move this down a little bit. So if we're solving by elimination, we are adding or subtracting the two equations to get rid of one of the variables. And the goal, or one of the kind of methods we can use, if we have the same sign, we need to subtract, regardless of what the sign is. If it's the same sign, we have to subtract. And if we have different signs, we need to add them. So this is something to keep an eye out for. This will help us figure out what we have to do, whether we add or subtract the two equations to find our point of intersection. So in the first method, or we're still going to, both methods we're going to look at is solving by elimination, but the first one we're going to look at, we're going to focus on getting rid of the x. Realistically, when you're doing these on your own, it doesn't matter which variable you want to get rid of. Oh, that should be get rid of up here. To get rid of. It doesn't matter which variable you want to get rid of. We're going to go through both methods just to show you that you get the same answer either way you do it. So in this case, we're going to eliminate x. So I'm going to draw a line underneath, and now I need to figure out, do I need to add these two equations together? Do I add equation 1 and equation 2, or do I subtract them? Well, in this case, if I look at the x's, which I'm going to highlight right here, if I look at these x's, the sign in front is the same. They're both positive. And if I look over here in purple, I've already made the note. If it's the same sign, I subtract. So I need to subtract these two equations. So equation 1 minus equation 2. So x minus x is just 0. And here next we have is 2y minus negative 2y. So this becomes plus 4y. One of the key things is you want to make sure that when you're reading this or figuring out what your operation is, you want to do this term, this operation with this term, right? So it's 2y minus negative 2y. So just keep that in mind. You have to go from the inside, from the term, to the outside for the operation, back to the inside for what the term is. Equal sign stays lined up, and then it's 5 minus, so we go outside, negative 11. So this becomes 16. When we go through, 0 can just get disappear, so we're at 4y equals 16. To get y by itself, I'm going to divide by 4, divide by 4. One side cancels out, and I'm left with y equals 4 as my final answer. Again, remember, we're trying to find the point of intersection. So the POI, we know from our last note, the point of intersection is just a point. Right now, I know that the point has a y value of 4. Now, to figure out the other value, I need to sub y into equation 1 or 2. So into either equation, and solve. So basically, when we find one value, we sub it back into the equation to help us find the other value. And that's what we're going to do right now. Again, it doesn't matter which equation we use. I'm going to pick the first one just for the sake of just picking number 1. I'll rewrite it. So x plus 2y equals 5. I now know that the y value is 4, so I can replace the y with 4. So instead of 2 times y, it's 2 times 4 equals 5. X stays the same, plus 2 times 4 is 8 equals 5. And now this is just a one-step equation. To get rid of plus 8, I have to minus 8 from the other side. One side cancels out, and I'm left with, x equals -3. So that means that the x value is -3. So my point of intersection is -3, 4, which is my final answer. So that is solving it. In the second method, still dealing with the same two equations. What we're going to do is we're going to eliminate y this time, just to show that we can get the same answer. Again, we want to remember that if we have the same sign, we have to subtract, and if we have different signs, we add our equations. So looking at my two terms, because I want to eliminate y, I need to look at the y values. So in this case, plus 2y and minus 2y. So the signs are different, which means I have to add my two equations together. So now I'm going to go through and add my two equations. X plus x is 2x. 2y plus -2y is just 0. And 5 plus -11 is -6. So this leaves me with 2x equals -6. This is a one-step equation. So to get the x by itself, I need to divide by 2. One side cancels out. So x equals -3. Again, remember our goal is to find our point of intersection, which is a point. And in this case, we now know that x is -3. We still need to find the y value. So like we did last time, we need to sub this value in. So we need to sub x this time because we found x first. Sub x into either equation and solve. So same thing we did last time, except we're subbing in x because that's the value that we found this time because we eliminated y first. So I'm going to use the first one again. X plus 2y equals 5. -3 plus 2y equals 5. All I did was replace the x. To get rid of -3, I have to add 3. Add 3 to both sides. The one side cancels out. 2y equals 8. I can divide by 2 on both sides to cancel it out. One side cancels out, and I'm left with y equals 4. So my point of intersection is -3, 4, which was the exact same thing that we found in our last method where we eliminated x first. So either way you choose, whether you choose to get rid of the x first or get rid of the y first, you can still find the point of intersection and it should be the same. If we want to check to make sure that we have the right answer, again, similar to what we've done in the past, we need to sub the POI into the equation. So we're going to take the point of intersection and sub it into both equations and check to see if left side equals right side or if basically it makes sense. So 2x or x plus 2y equals 5. I know my point of intersection. I'll write it down here. The POI is -3, 4. So when I plug those values in, I get -3 for x plus 2 times 4 equals 5. -3 plus 8 equals 5. and I get 5 equals 5, which does work. So it works for equation 1. Let's double check to make sure it works for equation 2. So equation 2 was x minus 2y equals negative 11. And I'm still going to do this exact same thing. I'm going to plug my point in. So negative 3 equals, negative 3 for x minus 2 times 4 equals negative 11. Negative 3, negative 2 times 4 is negative 8 equals negative 11. And when we simplify, we should get the negative 11 equals a negative 11, which does work. So this point of intersection is correct. It does work in both equations, and we can solve by either eliminating x or eliminating y first. In example number 2, we want to go through and do the same thing. We want to solve by elimination. So what we need to do is we need to add or subtract the equations. So we need to add or subtract the equations to get rid of one of the variables. However, if I look at the variables, none of the numbers in front are the same, right? X has a 3 and a 2, and the y's have a 2 and a negative 1. So none of those numbers are the same. So I can't add or subtract either equation, or I can't add or subtract the two equations together because that's not going to get rid of either variable. So that's something that we've noticed that we have to keep in mind. So the number in front of x or y must be the same. So in order to solve by elimination, the number in front of x or y, doesn't matter which one, right? Because we saw in the last example that we can solve either way. The number in front of x or y must be the same. Now, if it's not the same, we can multiply one or both equation to get it to be the same. So we can multiply one or both to get the number the same. So it's up to you. We can multiply one or both. I'm going to kind of show you something or a little tip to look for, but we can multiply one or both one or both equations to get the number the same. So looking at these two equations, the numbers aren't the same. I can't multiply 2 by anything to get to 3. I can't multiply 3 by anything to get to 2. And there is a common number between the 3 and the 2 of 6 if I'm focusing solely on the x's, these numbers here. So I can get those two numbers together by multiplying both equations. However, if I look at the y here, this y value has a value of 1. I can easily get 1 to be any number by multiplying it by whatever I want. In this case, I would want the y to have a value of 2. When you have an equation that has one of the variables like this, where there's a 1 in front of one of them, and they're not the same, so we need to change them, it's easiest to focus on getting rid of these variables. Because if I want to get rid of the y or eliminate y, that means I only have to change one equation. So what that means, I'm going to take equation number 2 and multiply it by 2. Let's color code this to make it different, because this was what we talked about in green. So I need to change one equation. I'm going to multiply it. So I'm going to take equation number 2 and multiply it by 2. So that means everything gets multiplied by 2. 2x multiplied by 2 is 4x minus 2y, because negative 1 times 2 is negative 2, equals 20. I still have my other. So I've multiplied one equation. So if I rewrite these two, 3x plus 2y equals -6, and then 2x that's the old equation. The new one was 4x minus 2y equals 20. And this is now where we can add or subtract the two equations. We can do that because the numbers in front, we'll put it pink to match kind of our colors on the side. The numbers in front of the y variable are the same. So if I refer back to above, because the signs are different, I need to add my two equations. So 3x plus 4x is 7x. 2y plus -2 is 0. And -16 plus 20 is 14. If I go through and solve, I get 7x equals 14. Divide both sides by 7. I get x equals 2. Because those canceled out. So again, the goal was to find the point of intersection. I know the x value is 2. Let's choose another color here. Keep it color coordinated. Go with orange. So I've gone through all these extra steps, getting the equations the same. I've added them to get one of the variables on its own. So now I need to, the last step, similar to what we did, sub x into an equation and solve. So this is the last step that we need to do. And this will most likely be the last step in every solving linear systems. So I'm going to take any equation. I'm going to choose the second one, 2x minus y equals 10. I know x is 2, so 2 times 2 minus y equals 10. 4 minus y equals 10. To get rid of the 4, put a box around it. I got a minus 4 from the other side. One side cancels out. I'm left with negative y equals 6. To get y by itself, because the negative does not count as being by itself, I need to divide by -1. Divide by -1. Cancels out on one side, and I get y equals -6. So that means my point of intersection is 2, -6. So this one had an extra step, and this is about as complicated as it's going to get. Well, there is going to be more complicated ones where you do have to multiply both equations by a specific number. However, if you're able to do something like this, and this is, I would say, very good. Again, we had to change one equation, then we had to add or subtract them to cancel out or eliminate a variable, and then from there we had to sub it back in and solve for the other variable to get to our overall goal of finding the point of intersection.